Ladies and gentlemen, a very warm welcome to the ninth edition of the TSDSI Tech Deep Dive 2026 conference. We are delighted to have you join us from 7th to 10th July 2026. This year's theme, Shaping the Next Decade of Telecommunications, 6G Standards, Systems, and Cross-Sector Synergies, reflects the exciting opportunities and challenges that lie ahead as we collectively shape the future of communications. Over the next 3 days, we will host 6 online technical sessions featuring distinguished speakers from across industry, academia, government organizations. These sessions will focus on global standardization activities and emerging technology trends across the following key areas: emerging 6G architecture options, AI native 6G, security, privacy, and trust in 6G, apps-based connectivity, technical feasibility trials and market dynamics, priority verticals and transformative use cases in 6G, open and interoperable systems for seamless connectivity of heterogeneous networks. On 10th July, we will come together for a hybrid segment of the conference in New Delhi, bringing together both in-person and virtual participants for an engaging exchange of ideas and perspectives. The final day will commence with a special session titled WRC 27 at Our Doorsteps, Perspectives on IMT Spectrum Priorities. This will be followed by the TTDD concluding sessions, during which summaries of the technical discussions held throughout the conference will be presented. We will then host a panel discussion on partner perspectives on the conference theme, providing valuable insights from our partner organizations. The conference will culminate in the valedictory session, which will be graced by Sri Jyotiraditya M. Sindhya, Honorable Minister of Communications. The session will also feature the presentation of the Outstanding Technical Contributions Awards for the financial year 25-26, recognizing exemplary technical contributions made within TSDSI ecosystem. Throughout the conference, we will showcase the groundbreaking work being undertaken within TSDSI, highlighting research, innovations, technical studies, standards, and ideas that have the potential to influence future telecommunications standards and systems. TTDD is much more than a conference. It is a platform for sharing knowledge, fostering collaboration, strengthening partnerships, and collectively building this future of telecommunications. We hope that over the coming days, you will gain new insights, forge collective, meaningful connections, and contribute to a shared vision for the next generation of communications. Thank you for being a part of TTDD 2026. With that, I now invite my colleague, Ms. Vaishali Aparwal, to take the proceedings forward. Over to you, Vaishali. Thank you.
Good afternoon, namaste, and a very warm welcome to all our distinguished speakers, delegates, and participants joining us for session 1 of TTDD 2026 titled Emerging 6G Architecture Options. We are delighted to acknowledge and thank Tejas Networks for sponsoring this session. I am Vishali Aparwal, working as a standards engineer at TSDSI. I am the session coordinator for today's session, and it is my pleasure to welcome you all. Before we begin, here are a few hygiene announcements. All attendees will be kept on mute throughout the session by default. Kindly post your questions in the Q&A tab of the conference tool. These will be taken up during the Q&A section. Questions in the chat box will not be entertained. If you want to enlarge the presentation, please click on the expanding arrow icon at the top right of the presentation screen. The tool is configured for HD video. You may switch to LD in case you are facing bandwidth problems. Attendees may like to visit the exhibit booth of TSDSI in between the sessions to know more about our work. Attendees can use the launch facility for networking. The launch will remain open till the end of the conference. The hygiene instructions are also available in the chat box. You may refer to them as needed. The conference sessions are being recorded and will be posted to the TTDD website in the next few days. Now, I would like to introduce our session convener, Mr. VK Roy. VK Roy is Advisor Networks at TSDSI. He served as Vice Chairman of ITUT Study Group 2 during 2022 to 2024. He has also made notable contributions towards international standards development, proactive participation in ITUR, ITUT, 3GPP, and SOP for Bhutan's mission under ITUD sector. He contributed significantly as drafting member of Bharat 6G Vision document. Now it is my pleasure to introduce the co-chairs of this session. Mr. Jishnu Arvindakshan is Principal Product Architect in the CTO's office at Tejas Networks with over 22 years of experience in telecommunications. He leads the company's 6G standardization and academia collaboration initiatives and is responsible for shaping its long-term technology roadmap. Dr. Sonali Garg is currently working with HFCL Limited as a senior member of technical staff, where she focuses on standards research and the development of SEPs. She also serves as Vice Chairman of Bharat 6G Alliance Technology Working Group and is an active contributor to ITUR WP5D SWG on radio aspects. Now, so with that, I now invite Dr. Sonali Garg to take the session forward and introduce key speaker and handle the keynote segment. Ma'am, the floor is now yours.
Thank you, Vaishali. Good afternoon and a very warm welcome to session 1 of TSDSI Tech Deep Dive 2026 on the theme Emerging 6G Architecture Options. Thank you, Shefali Sinha ma'am, for setting the stage for the conference. On behalf of my co-chair, Mr. Jishnu Arvindakshan of Tejas Network, our session convener, Shri Vijay Kumar Roy, and our session coordinator, Ms. Vaishali Agarwal, it is my pleasure to open what promises to be one of the defining conversations of this conference. Now, let me take a couple of minutes to set the context for why this session matters. Every generation we have understood so far has been at its heart for doing the communication better, faster, at lower latency. 6G is one of the generation being asked to do something genuinely different. We are asking the network to immerse in XR and holographic communication. We are asking it to sense, to detect drones, vehicles, people, using the same infrastructure that carries our data. And we are also asking it to do all of this sustainably. And you cannot deliver all those by adding features to an existing design. And when we ask these changes fundamentally, we have to go back to the foundations. And that is why we believe architecture, not just radio, is where the 6G real debate is happening. Now, where is this architecture discussions heading, or today where we are headed? The good news is that we are starting from zero. 5G gave us a strong foundation and 6G will build on it. But the direction of evolution is clear. The network is becoming AI native and cloud native, which means intelligence is embedded across the day one, not bolted on afterwards. And we are also, once we were thinking about this session, we also thought that the design philosophy is modular, simplified, and adaptive, because, and also we are talking about terrestrial and non-terrestrial networks, which are being designed together as one system today. So today, what we'll actually dig into will be the 4 questions. Essentially, one would be how much of the RAN and core do we re-architect and how much do we reuse? That is the debate over converged, disaggregated, service-based components. 2, how do communication, computation, and sensing come together as one integrated capability rather than 3 separate systems? 3, how do we design sustainability and energy efficiency in from the start rather than trying to retrofit from the later? And 4, how do we build resilience and interoperability across deployment realities as different as dense urban Europe, disaster-prone Japan, and rural India? Today's speakers sit at the center of exactly those decisions in 3GPP, and the choices they are debating now will set the baseline for the next decade. And that is what this session is all about. So we'll begin with the 3 keynote addresses. Can we move to the next slide? Yeah, so we'll start with the first keynote, which will be delivered by Mr. Alexey Kulakov. Can we have the speaker's bio, please? Thank you. So Mr. Alexey Kulakov is a distinguished telecommunication expert with over 20 years of experience in mobile network design, testing, and 3GPP standardization. Alexey currently serves as the 3GPP RAN 360 rapporteur, placing him at the heart of the effort to shape next generation network architecture. Alexey will present architecture requirements and Vodafone's view for 6G. There is no better place to start than with what operator actually require of the 6G architecture. Alexey, the floor is yours.
Thank you very much. I try to share my, actually I cannot share the presentation you have. Yeah, now. Okay. So I would like to start my presentation very welcome to all of you. And yeah, as already introduced, my name is Alexey Kulakov. I'm based in Germany and work for Vodafone for the last 25 years. So I have a little bit of history in 3GPP, as already mentioned. I will not repeat what was already said. So let's go over the Vodafone position to 6G, and let's start with the motivation. So first of all, what we expect from Vodafone, what is actually our motivation? First of all, we would like to prioritize the total cost of ownership, spectrum efficiency, energy consumption, and operational simplicity. So we expect that the next generation of mobile communication will become much more simpler. Another thing what we see as crucial is that the 6G is not a new system from scratch. It's an evolution. We had already several systems before, several generations, and we operate them successfully also in combination till today. So we see 6G as an evolution to 5G and not as a system from the scratch. Another important part is...
Can you just make it full screen? We are seeing it.
Yes, sure. So another important part is that the impact of early decisions. So we are now in a study phase of 6G, and every decision we do today, that will last forever. So we have to consider them very carefully. On IEML, that was already said, that is artificial intelligence becomes embedded in every system. So today, whatever meeting I start internally or externally, the first word is normally IEML. So it's not only about the new generation, it's about the processes in every single area of the system design and operation. And of course, we are also interested in the new services, and I will speak about that a little bit more later on. In regards to the requirements, what is really important to us is the spectrum. And we are very confident that in Europe, we will have at the end something about 200 megahertz per operating, upper 6 gigahertz. But also what is important is a low spectrum, low bands, preferentially 600, but we will see how it will develop in Europe. But saying that, we can remember the story from 4G. In 4G, 800 spectrum was a really game changer. What is also important is 5G, 6G, MRSS. So the efficiency of MRSS is crucial. I really hope that it will be much more efficient than DSS today between 4G and 5G because of the common signal design, but we really hope that the MRSS will be even more efficient. What is also important is uplink coverage. What we saw in 5G, that many techniques for uplink coverage were introduced in the later releases, and the adaptation of these techniques was low. So we expect that every coverage enhancements, especially in uplink, what we can introduce will be preferentially be introduced in the first release. Another point, which in my view is a
See,
little
I
bit
think,
under.
we are not able to this. You change the slide or you're on the first slide?
I'm on the second. Oh, okay. Sorry, I don't know what happens. I am on the second slide.
But we are seeing the first slide.
Okay. Which one you
Yeah,
see now?
now it's second slide.
Okay, but
And
if
it's still not
if I
full
may,
screen. It's still
yeah,
not
but
full.
if I do the full screen, it looks like okay.
Oh.
I try again. Which slide do you see now?
In the second slide now. Now it's
Okay.
full.
Okay. So sorry for that, but as I said, the upper 6 gigahertz is a crucial thing. 5G, 6G, MRSS, uplink coverage enhancement. They have to come in the first release. What we are also looking for is the coverage everywhere. That means that we are also interested in non-terrestrial coverage definition and design. Important point for us, we don't see that 4G systems will disappear, especially in regards to the IoT business. So we need a simple coexistence between LTE, different technologies, and 6G. Do you see the next slide? Okay, I don't know if you see the next slide.
Yeah,
You
we are
see.
on the third slide.
Okay, so then let's go further. I will probably not speak about the time plan. Everyone knows it. So we have a little bit less than 1 year for the study, and then it will continue most likely with the work item phase. And we expect at the end of the day, the first products somewhere by the beginning of 2030. But what is really good already that we took first assumptions during the study item for the layer 1 functionalities in regards to the waveforms, carrier bandwidth, minimum maximum UE bandwidth, coding. So these decisions allows us to speak with our vendors and see what is actually the hardware impact out of these decisions. Some decisions will follow in regards to shaping, higher order modulations, and so on. Based on that, we will need to decide about additional migration options. Preferentially, we don't like to have any additional migration options, but if we see that the hardware impact is there on the existing bands and obviously on the existing bands, then we might still require some of these additional migration options. What I would also like to highlight that we already took a first decision in regards to the interface between RAN and control and core network. So we decided that this interface for communication services will be point-to-point, and now we have to select within the RAN free group which protocol stack to use. We also decided to proceed with CU-DU split and CPU-UP separation. So that's a similar architecture as with 5G.
Let's see, we are not able to see the slide itself now.
Okay, I don't know what happens. So now, can you see?
So to share the screen, we are not able to.
Okay, so sorry, I can just try to share it again because somehow. Okay, can you see it now?
Yeah, we can see it.
Okay, probably I don't do the full screen if it's okay because it looks like.
Yeah, I think this is fine. This is fine.
Okay, so basically, as I said, the evolutionary 6G architecture. So RAN CN interface for communication will be point-to-point. We will need to see what is the protocol stack to adapt, and we will proceed with CU-DU and CPU-UP separation, but probably also enhance these options with the new functionalities or redistribute the functionalities depending on the requirements. Two areas which are important for Vodafone and are a little bit outside of 3GPP is the low layer split and service management and orchestration. And my personal view, it's very unfortunate that is outside of 3GPP, but that also means that our layer 1 design needs to be aligned with the development of the lower layer design in O-RAN Alliance. And the new services, so the architecture for the new services is the next, what needs to be decided. If there is a new architecture, what kind of interfaces, and I will speak a little bit about next. Can you see the next slide?
Yes.
Okay, so in regards to the terrestrial networks and non-terrestrial networks, so we aim the common design. We think actually we will have 6G over satellite, obviously the 5G, but for us it is also important that the legacy 4G is supported. And as you know, Vodafone has a cooperation with IST, and our aim is to provide the satellite services also to 4G legacy devices. And that's why it is also important, and we are very happy that 3GPP decided that there will be mobility between the 6G and 4G. The support of voice is very important from the day one also in this context, because if it's not supported from the day one, that introduces obviously also the limitations for NTN. And the spectrum. Spectrum is obviously very important. That's why if we can have a dedicated spectrum for NTN deployments in Europe, that would be a really good success. So IEML everywhere. And as I said, for me, IEML is becoming an integral part of modern solutions. So it's used already today everywhere. It is still not perfect. And if you look on this picture, I hope you can see it. I still didn't manage to get the picture correct. The word performance is written wrong, whatever I did. So it's not without mistakes, but it helps a lot in many areas already. And we use it also as a company more and more. But if you look on the applications using IEML tools or IEML algorithms, very often they have new traffic patterns, and the new system has to consider it. We also believe that IEML will be used more and more in the areas which are already started in 5G and will be started more in 6G, in the areas like channel state information prediction, compression, beam management, and other RRM measurements, for example, probably even more and more areas with the aim to reduce the signaling, to reduce the energy consumption on the base station side, but also on the device side. Data collection, that is the part which we have to decide where it is done, and if a new entities, new interfaces are needed. To be honest with you, we cannot answer this question 100% right now, because every interface we design means also the cost for the introduction, and we really need to understand why we do it. And because of that, we also need to look on the energy consumption and the processing power. Every use case for IEML requires additional energy and requires additional processing power. So if we introduce a new architecture, at least these two aspects have to be considered. Sensing. In sensing, it's actually very interesting, because in the last round plenary just a few weeks ago, we agreed on the first work item for sensing in release 20 for new radio. And that is the first work item officially agreed in 3GPP, mostly focusing on the monostatic sensing from the base station, aiming mostly to sense the drones. But it introduced also an architecture and the protocol stacks, and to me, this is kind of a basis. The 6G will introduce other use cases with additional benefits, especially combining it with the communication assistant sensing where the devices are involved. And obviously the 6G sensing requirements have to be satisfied and have to be standardized. The system impact on sensing is actually pretty huge in regards to the interference measurement, resource allocation, paging. Actually, many technical areas are impacted by introduction of sensing, and that's why we need to see what are, at the end of the day, the cost and the effort to introduce the sensing as such. And the question is, do we need a new architecture for sensing compared to what we agree for 5G? And what is the motivation? The answer on that is also not very clear, but we will see, because it really depends on the use cases we imagine to be useful and necessary for in time of 6G. What is also important for Vodafone is the security. That's why we are very pleased that the discussion on the security already started between RAN groups and SA3, the group responsible for security. There are many aspects. I go over a few of them. Now, first of all, obviously the privacy and security we need it for user plane and control plane, for communication services, but also for the new services once we start. For example, with sensing, we have to understand what does it mean from the security and privacy point of view. For the EA interface, we have now a discussion about additional security mechanisms, for example, to secure MAC control elements. And here, on one side, obviously, as an operator, we would like to provide a better secured system as such. On another side, we are really worried about the potential hardware impacts on existing bands, because that will at the end delay the introduction of the technology. So we need a good balance, and the decision have to be done very careful. The last aspect on the security, which is more in the area between RAN and core network, is the TLS 1.3. If you look into details, then we have to decide now which of the protocol stacks we are going to introduce for 6G communication services. And here, 2 out of 3 options, they require the usage of QUIC, which is based on TLS 1.3. And TLS 1.3 is an additional security layer with the requirements in regards to the key exchange and security infrastructure and so on. The question is, does it bring that much compared to the option where it does not exist? Is it really required? This decision will be made, I think, in the next half a year. Probably Sean in his presentation can say something more on that. And then my last slide would be about the control plane and user plane. So a few things to say here. First of all, we are very interested to optimize inactive state and simplify the paging, increase the time or decrease the time for the devices to become connected. We are very interested in all the areas in regards to the control plane information reduction, where it is possible, to save the energy on the base station, on-demand SIPs, on-demand SSBs. There is a concept of Gotia cell in RAN 1 and RAN 2 under discussion, where there is a kind of a one logical cell which combines multiple physical cells. So these concepts are very interesting for us to see if they have benefits, and some of them, in our opinion, they have benefits, some of them less. On the user plane, actually, if you look, the 5G user plane stack is almost like a 4G, and the 4G is actually almost like a 3G. But the applications are changing. We get more and more XR applications. The applications are using other protocols. So, for example, many applications are using QUIC and not TCP. So we see that the user plane adaptation is one area where we have really potential now to redesign the functionalities and see that it's more efficient and more suitable for the next decade or 2 decades where the 6G will be present. And one area which we also see as important is a service-aware RAN. So we would like that RAN is more service-aware, more aware about the characteristics of different application and can adapt the behavior accordingly to the needs of these applications. And last but not least, I started with the fact that we see 6G as an evolution, and that is why for us it is very crucial we don't define a new 6G core network. We see the 6G core network as evolution of 5G, and we would like to connect the 6G base station to the involved 5G core, where the 5G base station can also be connected to. And that is an important point, because if we define a totally new core network, then we, in our opinion, we will get the same as we have right now, where you have a 5G standalone core network and the half of the world have not switched it to, just because the decisions are not made. Some of the operators consider it as too expensive and so on. So in our view, one core network is a key. And with that, I would like to thank you, everyone, and sorry for some problems with the presentation. Thank you.
Thank you, Sean. Thank you, Alexei. Am I audible? Oh. Thank you, Alexei. It was a wonderful session. You have actually delivered the operator economics and deployment reality. We also talked about MRSS efficiency and day one uplink coverage, to the reminder that every new architecture must be justified by measurable benefit. So we'll take the questions in the panel discussion, which will be moderated by my co-chair, Jishnu, at the end of the keynote sessions. Having heard what operators require, let us now hear those requirements are being weighed and how these requirements are being weighed and translated into architecture options from the chair of the very working group where that debate is unfolding. Our second keynote speaker is Mr. Sean Kelly, a senior telecommunications standard expert who serves as the chair of 3GPP RAN 3 working group, the very group in which 6G RAN architecture is being studied and shaped today. Sean has led Nokia's delegation to 3GPP RAN 3 since 2012 and brings over 25 years of experience in the development of global mobile network standards. Sean will speak on 6G RAN architecture, balancing continuity and innovation, taking us from the foundations of 6G RAN evolution through the new drivers of AI, sensing, and data to the architecture options and open questions currently under study in RAN 3. Sean, over to you. Thank you.
Okay, thank you very much for that introduction. Hopefully you can hear me okay.
Yes.
Okay, so good afternoon, everyone. So today I'll share some perspectives on the 6G RAN architecture and the balance between continuity and innovation. So let me begin first in the next slide with a brief overview of the presentation. So we'll begin first with some foundations for the 6G RAN evolution, so including expected day one services and some key architectural design principles. The second part looks at new drivers that are influencing the architectural thinking in 6G, including AI, sensing, and data. And then finally, I'll offer a RAN 3 perspective on the emerging 6G architecture, highlighting some of the options currently under study, as well as a number of open questions that are still being actively explored. As you'll see in general throughout this presentation, and as alluded to by Alexei, many things are still at a very early stage of discussion. So my aim today is not necessarily to present, definitive answers, but rather to kind of explain some of the thinking behind the ongoing architecture discussions. So next, before discussing architecture, it's worth asking a very simple question. what is 6G expected to deliver when it's first deployed? And if we look ahead to 2030, the answer is that the vast majority of services will seem very familiar. Operators will still need to deliver broadband connectivity, voice, messaging, regulatory features, all these services that are expected today. At the same time, we can expect existing services to continue evolving. For example, through greater RAN awareness of immersive services like XR and gaming, improved integration of non-terrestrial and terrestrial networks. But beyond these familiar services, we can also expect the emergence of new services that are natively data-driven. So capabilities such as ISAC and AI/ML operations, which don't simply consume connectivity, they rely on the network producing, sharing, and exploiting information in brand new ways. So the key message from this slide is that 6G Day 1 is primarily about evolution rather than replacement. The service portfolio expands, but it builds on the widespread deployment of 4G and 5G networks. So next, having discussed the types of services that 6G is expected to support, the next question is, how do we maximize the value of the standards themselves? And we've learned a number of lessons from previous generations about what makes standards successful. First of all, avoid multiple options whenever possible. Introducing multiple alternatives for the same functionality end up increasing specification and implementation complexity and ultimately contribute to ecosystem fragmentation. Second is that we should focus on the mainstream. So architecture should focus on capabilities that can achieve broad adoption. And that's not to say that niche use cases aren't still important, which they are, but they are less likely to justify major architectural changes on their own. Thirdly, the initial release sets the baseline. So I think Alexei also mentioned this. Experience shows that architectural choices that we make early tend to stick with us for a long time and can be very difficult to change later. So that's why it's very important to get the key architectural foundations right from the very start. And then finally, end user visibility matters. So features that deliver clear value are more likely to translate from specifications into real deployment. So ultimately, these considerations point towards 4 characteristics that are important for successful 6G standards: simplicity, scale, readiness, and market relevance. So next, I'd like to speak about how these principles translate into key drivers for the 6G RAN architecture. And it's useful to view these drivers in sort of 2 complementary dimensions. On the one side, there's a focus on performance and operational efficiency. So this includes smooth migration from 5G, deployment flexibility, resilient and secure design, and continued improvements to the end user experience. So these considerations are essential to ensure that 6G can be deployed and operated in a practical and cost-efficient way while building on existing network investments. But at the same time, there's this second dimension related to scalability and extensibility, which is the ability for the architecture to support new capabilities over time. This includes a lean and implementation-friendly design, enabling new services, AI-powered network operation, and a more data-driven approach to system design. So taken together, these drivers highlight the central challenge for the 6G RAN architecture, which is how to evolve efficiently from 5G while enabling new capabilities that may require further architectural innovation. So this next brings us then to the central question on the next slide of the 6G RAN architecture evolution. How do we balance continuity with innovation? And this should not be viewed as a binary choice. So 6G architecture should not be framed as either purely evolutionary or revolutionary. Instead, the goal is a kind of disciplined evolution. So we should try to reuse proven 5G architecture principles where they continue to deliver value, while introducing targeted innovation where new capabilities justify architectural change. So on the continuity side, this includes principles such as having a very clear functional separation between the RAN and core and open multi-vendor interfaces. At the same time, there's areas where new capabilities may drive architectural evolution. So examples of this include native support for AI and data-driven operation, continued evolution towards a cloud-native environment, greater service awareness within the RAN. So the key challenge and an important focus of the ongoing work in RAN 3 is determining where is reuse sufficient and where is innovation actually needed. So next, let me now move to some of the new drivers that are influencing the 6G RAN evolution, starting with the biggest, which is AI. AI is expected to play multiple roles in future RAN systems. And one way to view this is through three perspectives. I think these are very well known. So we have AI on RAN, referring to RAN enabling and supporting AI-based applications and services. We have AI for RAN, referring to the use of AI to improve network operation and performance. So this, as Alexei alluded to, is not entirely new. We have already machine learning techniques being applied in operator networks today. The question for 6G is how these capabilities become more deeply integrated into network operation. And then finally, we have AI and RAN. So this refers to the broader interaction between AI technologies and the evolution of the RAN itself. For RAN architecture, the important point here is that AI is not just a capability that the network supports. It may also influence how the network is designed and operated. And as AI becomes more integrated into network operation, access to data becomes increasingly important. And this is one reason why data is emerging as a key architectural consideration for 6G. So the next and second driver I'd like to briefly highlight is ISAC. So at a high level, ISAC extends the role of communication infrastructure by adding sensing capabilities. The initial sensing capabilities already being explored in 5G, in particular GNOD-based sensing. Looking towards 6G, studies are now considering approaches that include UE-based and UE-assisted sensing. For the RAN architecture, the key point is that ISAC introduces new sources of information into the network. And as with AI, this reinforces the growing importance of data as an architectural consideration for 6G. So looking more at data on the next slide as a foundational asset in 6G, we see that in future networks, the data will support several different objectives. So first, data will enable network intelligence. So AI and machine learning functions depend on access to data throughout the AI lifecycle, including training, validation, testing, and inference. Second, data enables new services, particularly those that depend on large-scale or real-time information, such as sensing and advanced analytics and other new services. Third, data enables new opportunities for value creation through data exposure, data sharing, and potentially new service models. At the same time, though, these opportunities raise architectural questions around how is the data collected, transferred, and made available across the whole system. So this becomes clearer when we look at the range of data sources that are involved. So as on the next slide, we see that data originates from many parts of the system. So at the UE, this includes measurements across different protocol layers, service-related information, and application data. Within the RAN, it includes network measurements, sensing outputs, and data used to support RAN optimization functions. And then across the broader network, including the core, there's additional sources such as event exposure, analytics, and AI model inputs and outputs. Some of this information is needed in real time to support time-sensitive services like AI inference. Other data may be stored and used later for analytics or AI training. So the key message here is that 6G must support many different types of data, many different types of data sources, many different usage models. And this reinforces that data becomes a central architectural challenge for the system. So now let me turn to some of the architectural options under consideration. So on the next slide, still keeping to a RAN 3 perspective, I'm looking at the RAN core interaction. On the next slide, please. Can you still hear me? Okay. Great, so thank you. So we have first an option under study, which is, I'm sure, familiar to everyone, which is this point-to-point interaction or procedure-based approach. There's several reasons for considering this approach. First being continuity by reusing some familiar 5G design principles and supporting a smoother evolution from current deployments. Second, it provides consistency. So for 6G connectivity services, 3GPP has already agreed on a point-to-point model. And so extending the same approach to other services could simplify the overall architecture. And third, it can provide an efficient communication pattern while also supporting direct RAN core data transfer where large data volumes or low latency are important. So overall, this option builds on established RAN core interaction principles and emphasizes continuity, simplicity, and efficiency. However, the open question for this approach is whether these established principles remain sufficient as 6G introduces new capabilities and services. So next, we look at a second option under study, which is a service-based approach. And this extends the service-based architecture principles from the core network to interactions between the RAN and core. So in this model, interactions are structured around services rather than fixed procedures. And the main motivation here is flexibility. So this approach can provide a more extensible framework for supporting capabilities beyond traditional connectivity services. So this includes areas such as sensing and AI/ML, where the interactions may not naturally fit a procedure-based approach. It may also simplify the introduction of new services over time, particularly when interactions span multiple domains or span multiple network functions. And finally, it could more naturally align with cloud-native deployment models. So overall, this option emphasizes flexibility, abstraction, and a more service-oriented approach. The key question is whether these benefits justify the additional architectural complexity that a service-based approach may introduce to the RAN. Then we have also under consideration in RAN 3 on the next slide. So we just looked at how the RAN and core might interact, but an equally important question is how data is delivered across the system, regardless of the interaction model that we ultimately adopt. And we see today that the data delivery mechanisms have largely evolved independently across the RAN, core, and OAM domains. And as a result, we see different protocols are often used for different types of information. As we discussed earlier, 6G is expected to introduce a much broader range of data sources and consumers. So this raises the question of whether a more unified approach to data delivery could provide benefit. The one direction being explored currently is a common protocol framework that could support different transfer modes, including event notification, streaming, and file transfer. And the motivation behind having this common protocol framework is to reduce fragmentation, provide a protocol framework that's perhaps better aligned with cloud native deployments, and avoid duplication of common functions across protocol layers. And again, this remains an area of active study. The key question is where a common framework adds value and where specialized mechanisms may still be the better choice. So finally, in starting to wrap up, on the next slide, sort of looking ahead and trying to bring these elements together from a RAN 3 perspective, you can see a bit the confusion now as we reach more of the main 6G study where decisions begin to be necessary. We've discussed one of the central issues for 6G RAN architecture is how the RAN and core should interact and how data should be exchanged across different parts of the system. For the control plane interaction, one of the key considerations is the balance between procedure-based and service-based approaches. So this involves some familiar architectural trade-offs. For example, determinism versus abstraction, efficiency versus flexibility, complexity versus extensibility. Then data exchange introduces a similar set of considerations. Should information be transferred more directly between network functions, or should it be supported through more common service-based mechanisms? And here the answers likely depend on factors such as latency, scale, data volume, and operational efficiency. The important point I'd like to leave you with, though, is that these are not simply technology choices. These are architectural trade-offs. The objective is not necessarily to identify one single solution, but to determine where continuity provides the greatest value and where new capabilities justify architectural innovation. So all of these topics remain under active study in RAN 3, and I expect they'll continue to be an important focus as 6G architecture evolves. So my last slide, just to close with 3 key takeaways. So first, 6G RAN architecture is about balancing continuity and innovation. It's not a binary choice, but a disciplined evolution that builds on the strengths of 5G while introducing change where it's justified. Second, data becomes a central architectural consideration. So beyond enabling AI and new services, it's increasingly shaping how different parts of the system interact and exchange information. And then finally, from a RAN 3 perspective, the architecture is still evolving. Multiple options remain under study, and our task is to evaluate the trade-offs. Develop an architecture that's both practical to deploy and capable of supporting the next generation of services. So with that, thank you very much for your attention, and I look forward to the further discussion.
Thank you, Sean. It was a comprehensive view, and specifically it was coming from RAN 3 chair seat. So particularly we were, and of course, we got an awareness about the of innovate to enable new frontiers. There was a candid articulation of the open questions on RAN core network interaction and data delivery. As well, we'll talk more about that in the panel discussion. Thank you. So from for our final keynote, shaped by the imperative of connecting Since joining Entity Docomo, can we have this? Yeah. Since joining Entity Docomo in 2004, Mr. Tanaka has built extensive expertise in mobile technologies, international standardization, and telecommunications innovation. In his current role, he leads Docomo Euro Labs activities in shaping future mobile network architectures and advancing international collaboration. Tanaka-san will speak on emerging 6G architecture options. Tanaka-san, we look forward to your address. Thank you.
Hey. Thank you very much for your kind introduction, Ms. Garg. Let me, first of all, open my file. Can you see this now? Thank you very much. Okay, so let's start. Hello, everybody. My name is Itsuma Tanaka from Docomo Euro Labs. And today I am representing Japan and NTT Group. NTT Group is half nationally owned big telecom company. And NTT Docomo, I think we had some business with India a couple of years ago. The mobile service division of big NTT Group. And NTT Group consists of like IT consultancy and fixed service, but I am from the mobile section. And where I am leading Docomo Euro Labs, it is a center of excellence and NTT's strategic standardization base in Europe. It's in Munich, Germany, and we lead topics like, well, 6G and AI native architecture and operation management for pursuing operational excellence of the telecom industry. So that's where I am from. And yep, our mission is bridging the worlds through unified standards. As the previous speakers, we share the same view. We want unfragmented, unified standards to make the innovation happen globally. And it's accessible for everybody. And we believe standardization is a really strong tool to achieve that. So from this standpoint, I am going to talk about our 6G today. This 6 element are the value, what Docomo thinks is the value of 6G. So connectivity everywhere, sustainability, operational efficiency, and of course, better customer experience. And it should support AI applications, and also the network shall be supported by AI applications. But in my talk today, I think I will focus more on this part, connectivity everywhere and network resiliency. And why does network resiliency and big connectivity matters from Japan? Because Japan is a country full of natural disasters. Earthquakes, tsunamis, volcanoes, and big typhoons, you name it. It's a department store of all different kinds of natural disasters. And since Docomo's establishment in early 1990s, it has been our strong mission. Everybody in Docomo has this strong sense of mission that we are here to connect people all the time, whatever the circumstances are. And we have so much experience managing after responding, recovering from natural disasters in Japan. Before going into 6G, here's a bit more background. Yes, this was the earthquake which happened 2 years ago in northern part of Japan, the Noto Peninsula. This is what we do. So we send lots of people over the broken, completely destroyed road and streets, try to set up the broken base stations. Many times power is missing. So getting the power is a big problem. Yeah. And so, yes, we do this today. We do this on the land and also from the sea, as you can see. the ship here. So reconstructing coverage is a very important mission, and that one has been doing. And as for this 2 years ago earthquake, satellites played a big role, very big role. It was used as to complement this loss of coverage. And so the coverage from the sky proved it's very useful. Yeah. So this is what we have today. So geo satellite, LEO satellites, and now we have direct to device services as well. But towards 6G, we want to bring these use cases, scenarios further. Yeah? Satellites, it's proven that it's very useful when we construct the coverage, even in those emergency scenarios, plus rural areas. So what we want to achieve with 6G, with satellite, is to extend the area coverage significantly, and hopefully super fast gigabps grade communication services everywhere, and covered sky, sea, also in the space. And that those are the places where traditional base stations cannot reach. Also, in case of those emergency situations, those are usually the places where it's difficult for our engineers to reach on the ground. Okay. So yeah, one of the missions from our point of view, 6G is a great opportunity to achieve this and extend activity, support activity, business, society, whatever, okay, logistics, industries, cars, anything. So it's going to be integral part of everything in our view for the 6G era, okay? And this is the NTT Group's vision. We have a brand called C89 that kind of collects all the satellite related activities. Yeah. So in our plan, in our vision, we have a geo, LEO, and lower altitude apps combined with the ground network. And that's the envisioned architecture. Like geo, LEO provides large coverage, whereas lower altitude is expected to provide higher bandwidth, speed, whereas the system on the ground provides large capacity. And so it's three-dimensional. And this kind of requirement and use cases are to be integrated in our requirements towards 6G. Okay, so in standardization perspective, I think I skipped this. We've already seen this in the past. Yep, so now right now, many companies are participating in 3GPP to define all the network architecture and taking into the requirements. We've seen from the past previous speakers, sensing, security, data, AI integration, everything are now being stewed in 3GPP to come to hopefully some consensus. Yes, and it's still a long way ahead. I mean, it's easy to say finding common architecture is what we want, but of course, everybody has different requirements, different priorities. So it's going to be a really interesting discussion for the next couple of months, couple of years to come to the conclusion. But that doesn't mean we cannot do anything. At the moment, based on the standards today, even before 6G, we have lots of architecture options already. So from the left, oh, sorry, the device is missing on the picture, but yes, independent proprietary, like traditional geo satellite solutions has been already available, and it's outside standardization, right? Like Docomo's case, we have a geo satellite, really traditional, big mobile receiver. Okay, that's that. And another solution now becoming popular is the roaming architecture-based solution, where satellite operator provide a ground station with a specific PLMN, the network ID, fully registering ITU for the satellite service, plus, well, it's LTE today, but LTE RAN and LTE core network. And the beauty of this is like in whatever telecom operator, like as Docomo, if they want to have the satellite coverage, simply connect with the roaming architecture. This architecture option is already fully supported with the existing 3GPP standard. So it's, if it's LTE, it's release 8 even. Yeah. And the other ones that we see in the market is this, what I call integrated architecture. The point is that the architecture uses network sharing. So the radio coming from satellite uses the network ID of the telecom network where the customer SIM card is belongs to. So these architecture options are already supported. And so what 6G will change is basically how more closely, more integrated the network operation and like handover from the ground or with the ground, with the satellite. That is basically the main questions being discussed in 3GPP. So they try to define NTN as the 6G RAN, a type of 6G RAN, so that like handover between satellite and ground can go even more smoothly. So the system doesn't treat satellite and the ground network as two separate entities, but more integrated one. So those improvements that we hope to see with 6G. But probably given the situations already in the market, like already a bit fragmented, let's see how 3GPP will decide as the preferred architecture. Okay, but yet we have so many open questions in 3GPP today. So first of all, the service scope. I think there are some point raised by the previous speakers, support of like voice service or emergency voice support. How much of this is needed? It's still open. And so yes, IMS, IP multimedia subsystem. That's the system beyond our voice over LTE, voice over 5G NR today. How can we integrate this into the NTN system? And yes, and roaming policies and multi-orbit, as I said, 3D network architecture. We have LEO, GEO, LEO, lower altitude HAPS, and ground stations, the 3D, and they are all moving around. How do we manage the stability of the control? QoS, traffic, routing, most optimal routing path, etc., etc. And handover, number 4, the handover is really an interesting question here as well. And hosting. So again, one of our missions, well, many companies actually talk about like having a data center in the space. How to discover the data center or the secure hosting environment, how to select, how to be consistent in the space. Those are the big questions. And lastly, well, maybe there are more questions coming up in the later phase, but yes, energy and resource efficiency, the big question. Although many satellites are solar powered, but yet, especially when it's integrated with the ground network, management of power is a very important aspect. Right. So to conclude my presentation, I think we went through with the focus on NTN, but there are so many more issues around NTN. Yeah. So use of AI, how deep can we integrate that? It's not just a technological question, but involves lots of organizational business process change internally, okay? And sustainability, energy, and supply chain, how to become environmentally and business sustainable is again a big question, okay? And efficiency is related topic. How can we optimize the resource use? And what is it? What is the required functions and features on the network to support those AI applications? In the end, all of these together, our customer experience will improve. Those are the open 6G questions, yes, but no single organization can build the future of 6G alone. Standing from Japan perspective, I think our Prime Minister visited India a couple of days ago. So those friendship collaborations are very important for us to jointly create the standard, the system that everybody will be able to access. Okay, so more last slide. Yes. My real conclusion here. Yes. So let's go together. If you want to go fast, we can go alone. But with 6G, we definitely want to go together. Because AI, space, sensing, lots of requirements are now very universal. Everybody has the very similar requirements. I'm sure we can go together. Not just telecom industry, but yes, from academia, or any other business, those industries and lessons from 5G, bring everything together as collective intelligence, and we can make 6G happen. So thank you very much. That was my presentation. Thank you.
Thank you, Mr. Itsuma Tanaka-san, for sharing Docomo's perspective on the value of 6G, which included network resiliency born of Japan's hard-won experience with natural disasters. Your image of a network that must keep people connected, no matter where people are, no matter what happens, is a fitting note on which we broaden our conversation. We now move to the panel discussion, where we will bring operator, vendor, academic, government, and services perspective into direct dialogue. It is my pleasure to hand over the moderation of the panel to my co-chair, Mr. Jishnu, Tejas Networks. Jishnu, over to you. Thank you.
Thank you, Sonali. I think maybe we can get all the panelists on the stage. While we get them in, it's my pleasure to introduce all the eminent panels, including all the keynote speakers who will be joining us. Alexi from Vodafone UK, Itsuma San from NTT Docomo, and Sean from Nokia. In addition, we have other 4 more panelists joining us. We have Ashok sir. Can you change the slide? So Ashok sir is an ITS officer of the 1993 batch with over 30 years of experience in telecommunications. He's currently serving as DDG SRI at the Department of Telecommunication Headquarters. He's also a telecom advisor and OSD, Officer of Special Duty to the Secretary, Government of India. Our second panelist is Javan. He's a senior consultant and strategist. He's a senior director of strategy at GTI Alliance and leads the 6G architecture work group at 160 Association. The next panelist is Ravi. Ravi is a global head of connectivity practice at Wipro Engineering, bringing close to 29 years of experience in connectivity products and network engineering. And the next panelist is Satish Jamadagni, whom all of you may know. He is also the current chair of TSDSI. He's also the senior vice president of and head of global standards at Reliance Jio. He has over 25 years of industry experience in telecom vertical. So I will now have all the panelists, and I will start the question. Can I start that, or? So my question to Alexi, to start with you, what are your key expectations from 6G? I saw you already mentioned sensing and some VR applications. So my question is, as a network operator, how comfortable are you to go to a completely new architecture? You mentioned it should be an evolution, but it may need some hardware upgrade and some replacement to support all these things. How comfortable are you? So, Alexi, maybe you can give not just a Vodafone perspective, but a European perspective on this.
Thank you very much. Very good question. To give European perspective becomes even more challenging than to give Vodafone perspective, because we have over 27 jurisdictions with different laws and different economical situations and scaling factors and so on. So let me give you not even Vodafone perspective and not a European perspective, but probably my own perspective. So if you force a company to invest into something where you get the same or approximately the same as you have right now, the companies will calculate and probably not invest. So if we introduce the functionalities which requires the hardware changes on existing bands and the existing hardware, that have to be really, really carefully be considered. It does not mean that there should be none of them, because obviously without any changes, you will just not get any improvements. But if you consider them as a mandatory from the start and so on, then I think it will create limitations on the deployment. So people will not just think longer if they need to deploy the 6G networks, if it's the right time and so on. So my feeling is that it would be great to have this mechanism requiring the hardware changes, requiring the new hardware, and implement them in the new bands. So as I said, for example, in upper 6 gigahertz, there is no problem as such, because we need to deploy them anyway. Yeah. But for bands we use today, we need to be very, very careful. That's why I made this example with the MAC-CE. Yeah, with this MAC control element security. It's a great feature. But if that becomes a mandatory feature from the start, with a clear evidence that we have to upgrade our hardware, what do we get back? We use the MAC-CEs for decades as of today. Yeah, so that's always a balance. But again, it's not saying that we should not standardize it and we should not do it in the first release, but we should be carefully consider what it means for the operator in terms of the investments. That would be my personal view, not European and not Vodafone.
Thank you, Alexi. Good to hear on that. Let me take the same question to Itsuma-san. We heard a lot of NTN connecting all the space network. It was almost looking like we are about to reach moon and set up a network there. So what is your expectation? Are you actually trying to go out of Earth and set up a network? And as a operator, how are you in planning your investment of setting up a satellite network to support all the resiliency needs which you're discussing in your slides?
Thank you. Yeah, I cannot really tell you the figures, but yes, we have been investing quite a lot on the satellites for now. At the moment, 6G is not ready yet. It's based on the traditional 4G and the proprietary solutions, yes. But we have like a lot of, as I said in my panels, my presentation, lots of satellites already flying. Use cases are really clear. The challenge is about finding a sustainable business model, because flying rockets, satellites into the space is very expensive. Managing the services up in the sky, it's also very difficult. At the moment, like majority of our services are like mostly like government funded. But the big question is there, whether non-public funding can really support the business model. And we are trying lots of like enterprise solutions around this. So yeah, let's see how that turns out.
Thank you, Itsoma. So can I now go to Satish Jamadagni on an Indian opinion? I think you have sort of rolled out the largest 5G network in India, and you have been figuring out a new use case on FWA. What do you see as the key expectations from 6G, and how comfortable are you to change the network architecture, hardware upgrades, and all that for 6G? Especially knowing that 5G is still it's still not sort of ROI positive, if I have to say. So Satish, over to you.
So from a 6G perspective, there's been quite a substantial amount of decisions which have been taken. From the RAN perspective, there is a decision to at least support all the existing 5G waveforms. O-RAN as an option was always there in 5G as well. So whether it is formalized in 3GPP or not, that option was always there. So there is nothing new as far as that is concerned. Core network functionalities in 6G, I don't see anything happening except for engineering, whatever, cloudification, etc., which I believe is more of engineering than functionally. I'll be surprised if anything changes in the core network from 5G. So architecturally, there's nothing which is happening in 6G. And there is one bad decision, in my view, which is a very bad decision, which has already been taken in 3GPP, which is supporting fixed wireless on the same mobility platform. We were hoping that in 6G, at least the fixed wireless, architecture would evolve independent of your mobility architecture. That has not happened. Fixed wireless forced on mobility architecture, which I believe is a very wrong decision, because this sort of forces. I believe that this will force a lot of proprietary fixed wireless solutions in the market going forward. As far as AI is concerned, let me quote a very interesting story which has happened in SA4 3GPP. I'm not exactly sure how many of you followed this. So there was this one company which brought in a codec, voice codec, AI trained voice codec, which is supposed to achieve extraordinary compression, around 1 kbps compression. It's quite a bit, actually. I mean, if you look at any of your previous generation 8 kbps, 16 kbps, whatever voice codecs. Now this codec will not be accepted because 3GPP is taking a decision, or decision is yet to be taken. But then the consensus or the popular view seems to be that the training data set used for this codec has to be made public, or in general, the working group has to come up with a common data set which is agreeable to all. That means in the AI world, data is proprietary. The data you play around with is your secret sauce, and you're asking that to be made public or brought out onto the table. So this is more than what is happening in SA4. This is a dilemma of AI. If you go in the direction of standardizing AI, then you're trying to normalize all of these data sets from different operators for whatever functionality. They say, bring it on to the table, let's normalize it. Then what is new? There's nothing new. The whole secret sauce of AI is dead at the beginning. So proprietary solutions will thrive, and the companies who have the proprietary solution will never be able to bring it onto the table, etc., etc. It's a dilemma. Now, given this story and given this dilemma, what do you expect of AI bringing onto the table in 6G? It's going to be confusion, experimentation, a lot of playing around here and there, which is all fine. So to me, 6G is going to be an experimental generation. I hardly see if there will be any serious investment in 6G. You talk of ISAC, radar is an old technology. There are a lot of private companies who give you dirt cheap radar technology. You just put it onto your tower today. You're up and running as far as ISAC is concerned. So you can always integrate it at the application level. Fine, yeah, done. Satellite, too expensive. Every month, the American biggest satellite company, which is, there are about 5 to 8 satellites which drop back to Earth. That means they're destroyed. Every month you have to keep putting up 8 satellites again back to orbit. Very, very expensive proposition. Very few companies in the world, and that too with extensive government support, will be able to sustain this kind of a business. And let me stop here. You also have HAPS, which is an alternative. So let's see how it will all play out. To me, I don't see 6G going anywhere from an implementation perspective, because 5G is still evolving. MIMO efficiencies of 5G is still yet to be realized. A lot of things yet to be stabilized over the next 5, 10, whatever number of years as far as 5G is concerned. 6G, in my view, is an experimental generation. I will be very skeptical if operators will pour in money, billions of dollars, like the way they did for 5G. Thank you.
Thank you, Satish. Yeah, that was a bit controversial. Let's see. Let's put Sean itself on the hot seat. So you can see 3 operators have different view. At least Alexi was okay to change slightly some hardware. Itsumo has worry, but still okay to put some satellites. But yeah, I think from Geo, it looks like an experimental thing. So you can see, as you mentioned in your slides as well, there is both innovation which needs to happen, and there is some continuity which needs to happen. And I think you can hear from all 3 operators, coverage and energy efficiency is 2 key important pillars. So that is from a continuity perspective. And then the other thing is that 2 new applications, one is AML and another is ISAC. Both of them are also sort of key applications which are coming up. How, as a chair of RAN 3, how will you make sure all of these are possible to be done, meeting all the expectations of at least 3 operators from 3 different continents now?
Yeah, that's a very good question. Yeah, I think one of the fundamental challenges for 6G, we're trying to introduce some new capabilities like AI and sensing. These introduce a lot of additional processing and signaling and data requirements. But at the same time, operators still expect, better coverage and more improved energy efficiency. And I think probably historically the answer in 3GPP, at least in 5G, is okay, let's make a new work item, we'll add some new functionality, it'll improve energy efficiency, it'll improve better coverage. But probably from the RAN 3 perspective, where we look more at architecture, I would say that in 6G, our goal would be, try to make the system more intelligent, try to make the system more adaptive, and try to solve these very important issues with operators in that way. So for example, of course, with AI, it can consume, resources, energy, but it can also improve energy efficiency, through more intelligent resource management, traffic adaptation, network optimization. And I think similarly with a more data-driven view of the network conditions, it can help improve coverage or make, more efficient use of spectrum. And I think also in 6G, I think it can bring more benefits with additional flexibility in the architecture. So functions don't necessarily need to be deployed or activated in the same way under all conditions. if we have a more cloud native or service-oriented architecture, this could create some opportunities to scale capabilities based on demand and somehow, make more efficient use of compute resources. So I heard some skepticism about 6G, but I think, there can be some strong motivations as we move forward in terms of even, OpEx, just being able to operate your networks in 6G more efficiently with, let's say, some new innovations into the RAN architecture.
Thanks, Sean. Let me bring Professor Java in here. Anything to add? And you also are part of GTI Alliance, so you can also explain how alliances can help in bringing all these different opinions together and at least get an architecture which all of us can implement as a vendors and all that stuff. So over to you, Professor Javan.
Yes, thank you very much for having me here. Thanks to TSDSI and all the panelists and the distinguished hosts and guests. I think I agree with a lot the consensus that that we need things that are feasible, that we need things that are simplified, modular, and cost-effective and possible. At the same time, there are opportunities. So as very well said, and I think Sean also put it together very well, there is this question of, for example, how we create versatility so that we can use what we need when we need it. But at the same time, I think the role of alliances and research is to address these. How do we come up with these opportunities and transformations everyone is interested in, and at the same time make them as simplified and possible? Notice when we bring energy and ubiquitous connectivity and AI together, it can also point to not good directions that we need to work on, like how do we have collaborative systems or cooperative, for example, UEs, devices and MNOs, coordinated UAVs, even for prediction, a swarm of UAV trajectory. There are new possibilities, even with the smart beamforming, spatial and temporal coverage, that we can work on in the intersection between these things so that we provide dynamic allocation. I think it was also mentioned by Tanaka-san that there's need for integration of NTN. As you would agree, there's also this, to do that, we need dynamic coordination. So the best of AI would, together with sensing, is to provide that knowledge, that coordination, that energy efficient approach. Now, when it comes to energy efficiency, it goes across standards, as you know, from protocols to reference signals to states, like very well said, fixed wireless access has its own integrity and goes to equipment and material, but a lot of it is also design, engineering, operations. And when it comes to dynamic allocation, in addition to alternatives such as renewables. If you allow me, with respect to alliances, it was very well said that no single organization can build this alone. So even though we know that the release 20 and going to 21 will set a baseline, there's still a lot of work together, including research, to shape, to make that HAPS work, to make that satellite, the 3D connectivity work, to do the beamforming. Beamforming is an amazing area we are trying to exploit in terms of following the user, spatial as well as temporal, and making things simple. Latency will be a big thing. We are introducing more complexity, more data with large models and so on. How are we going to address for example, industry solutions? There are conflicting objectives that we can work as a community. There are heterogeneity in that needs collaboration because everybody has their own interests, their own operational models. There's several hundred, as Sean and others know, in standards. And finally, of course, in terms of agentic, generative, physical AI, we need governance. We need, to address bias. We need to address responsibility. And with validation, this is the last thing I would say, that with validation from standards to alliances to research, we can see that the value speaks for itself. Like when I was at NGMN, one language that we adopted was anything new should justify itself. So I think there's a lot of work to shape the 6G era together and go together. I pause here for your follow-ups. Thank you.
Thank you, Chairman. Thank you. That was a good response to this. And let me now just shift to a Government of India representative here. He is from Delhi DOT. So they have also been trying to get more startups and MSME to get into the 6G ecosystem. So there has been a lot of policy initiatives which were started by under Ashok sir. So can you just explain how do you think that will help in the standardization effort in the first step, and then how it can help in commercialization of 6G technologies, especially from the startups? Over to you, Ashok sir. Ashok sir, can you hear? You are on mute, man.
Yeah, sorry. So thank you, Jisnuji, for the question. And before I answer your questions, let me first congratulate all the speakers for wonderful presentation, showcasing what can be the 6G architecture options, and also the contradictory views of different speakers and panelists on the issue. But nevertheless, whatever the option 3GPP and otherwise local standard bodies decide, it is for sure that we need to create ecosystem around 6G so that it becomes success. So on the same line, Government of India is following ecosystem driven approach for development of 6G, whatever government can do on that particular part. For example, when I say ecosystem driven, I talk about startup, I talk about MSME, I talk about academia industry, which includes OEM, telecom service providers, so everyone together, because every one of these elements are actually party to these development and deployment. So you cannot just leave alone one or other. So coming on to the policy aspect, that what kind of policy Government of India is following in respect of 6G. So as you may be aware that till the time we had 4G, the government intervention was very, very minimal or sort of a no interventions. Only with the 5G onwards, some intervention have started. And for the first time, we did end-to-end 5G test bed at IIT Madras, so that we have a lot of know-how in our country about that. And as you may already be aware that we also created end-to-end 4G stack, which is getting deployed in BSNL, about 1,100,000 towers, which are now operational. So that's like Tejas is radio, C-Dot is core, and TCS has done system integration of that. So we expect that similar stack we will continue to develop for our country, indigenous in the sense that we have control. Seeing the geopolitical scenario, it is important for rather every country to have control over whatever telecom system we deploy. So the policy around to achieve these objectives, the policy which we are following today is based on the life cycle itself of the making of mobile technology, which is a cycle of 10 years, starting from standard development and parallel research activities to the standards, and then pilots, and finally the commercial deployment. So to strengthen the standard participation by startup and MSME in particular, because the industry per se have ability to participate on its own, but our startup who can develop newer technology or MSME. So we are supporting them participate in 3GPP meetings by way of sort of subsidizing the fee which they have to pay to TSDSI or for 3GPP, or the travel support we also want to do this year. The second aspect, if you look at, is that how to promote creation of IP and SEP by the entities. So, for example, talking about whole of the government approach, not only DOT, MITI has some scheme called IP Catalyst scheme, wherein they help you file your IP onto different international forum, be it PCT or European Patent Office, and they also sort of help you on the other activity. In addition, we are also kind of collaborating. We are promoting collaboration through Bharat 6G Alliance, so that industry academia collaborate together to bring technologies for 6G, which if you are aware of, they have multiple technology and other working group working on a different topic. In order to have some of the technology developed, the DOT, through its scheme called TTDF, Telecom Technology Development Fund, is sort of supporting 100 such projects on different 6G related topics. In addition, if you look at ANRF, they are also supporting a few of the 6G related projects. And the RDI scheme, which is very 1 lakh crore value scheme, wherein the companies are being supported through a very low interest loan or equity. That scheme has already started, and a lot of our telecom companies are becoming beneficiary of that particular scheme. I think this will help in indigenous R&D, deep tech innovation, etc. In addition to that, our country have launched a lot of strategic mission mode approach. For example, be it India AI mission or ISM semiconductor mission, which you have, or the National Quantum Mission. So all of these have a telecom component, and this will actually bring capabilities in our country related to AI, semiconductor, quantum technologies, and so on. In addition to this, we are aware that during our 5G, we could not do 5G use cases in a big way, whatever was the reason, all of us know. So we created sort of 100 5G lab across higher educational institutes. And now they have started doing some of the use cases around that. And also they are trying to file certain IPs, and also at least we are creating an ecosystem where research can happen not only on 5G, but on further technology, emerging technology, which may come. So some sort of ecosystem development. So what we expect through all these initiatives which we are trying to take is that we should strengthen the contribution which is going from our country to ITU, to 3GPP 1 to 1M to M and other standard bodies. And we hope that the IPs and SEPs into the standard also contributed from our country, India. And with this, we hope that will play a sort of a decisive role in 6G. So with this, thank you.
Yeah, sure, sir. It was quite informative on the various policy initiatives which you have been taking. Now, coming to the last panelist, so he's from service industry, and he has been seeing a lot of those AML already taking shape. And at least we hear, at least in newspapers, on all the disruptions happening in the service industry. So maybe he can update us on what exactly is happening in AML and what expectations he has from the telecom network from an AML perspective, where it's basically, you can consider all of us as network for AI. So what is the level of automation, intelligence, and operational efficiency you are expecting from 6G network? Over to you, Ravi.
Thank you, Jishnu, for the question. I think, all of us are aware, like for last 24 months, we have seen this AI being adopted in the SDLC lifecycle, the software development lifecycle. I think not only software development, across various processes, people are adopting the AI. And we have seen some results coming in with respect to the higher productivity and improved quality of the product, and also shortened cycle time of the development, right? So we see that the momentum is improving day by day, and there's a lot more maturity is coming in the AI/ML models, and that is leading to a larger productivity, quality, and so on. I think in the similar way, we see that the networks and the network operational organizations are going to adopt the AI over a period of time. Of course, telecom is very regulated, so the adoption might take some time. And we see that each operator is unique across the globe because of their subscriber base, their technology stack, the level of R&D capabilities that they have in-house, and so on. And we think that the way the AI is disrupting the software development lifecycle, same thing with the network deployment lifecycle. We see that AI is going to assist the various personas involved in building the network, whether it's a plan, to design, to build, to operate. And Telemanagement Forum has defined a certain amount of maturity, but I think maturity is one way of looking at it. The more and more operators are looking at it is where is the return on investment for each of these AI interventions, and how do we do that effectively to generate the maximum return on investment, then reaching a certain maturity level as defined in TMF standards. We see that the AI is going to bring in three distinct things to the telco or the network operators. One is the AI in the autonomous networks or a network lifecycle management. The second is how do you bring this AI nativeness to the entire stack of the telecom, be it at the baseband level to the higher level applications, how it can influence the spectral efficiency to the energy efficiency, essentially replacing everything that is being done today with the rule-based system to a much more adaptive and much more environmental adaptive models that are going to influence the decisions made by these algorithms running in various layers that can influence the improvements in that space. Third, we see that AI is also going to be a new revenue generator for the operators, with the 6G bringing a lot more capability. And that's the third piece, right? From a autonomous network operations perspective, we do see several challenges the operators are facing today. One, definitely the data foundation. Not many of them have organized their data effectively. The quality and accuracy of the data is also a big factor for building these agents, right? And in that context, again, data is not going to reside at one place. How they build the data fabric across the various sources of the data and bring that cohesively to these agents for the consumption is one aspect. Second, we see that the compute fabric is also a big challenge. We need to have the larger compute power to run these agents, and then the inference fabric that's going to run on top of it. And while it's a technology is one aspect of it, the data security privacy is one of the concerns. And many of them today have done a lot of POCs with large language models or frontier models. But we think that eventually the telcos will embrace their own small language models or their own language models with their own proprietary data being used to train these models. That would help them to make their own token generation capability. So that's going to be critical for them. While the technology side, one aspect of it, we think that the business process that are defined today for human-centric operations need to change for AI-driven operations. Secondly, the workforce that is behind it need to transform for AI-enabled operations. And at the same time, we see that the technology foundation has to be done, thinking that the 6G is going to bring a lot more complexity to the network. It's not about solving today's problem, but how do I build the foundation for the future things, right? And as you see, the 3GPP has already defined not only the connectivity as a foundation or improving the connectivity, but the compute, data generation capability, and also the AI capability are the three cornerstones for the future standards. So that brings a lot more data generation capability in the network. whether operators will have all that capability to bring the required compute power at the edge, whether they will have the hosting capability at the edge for serving these AI models. So will they have sufficient power resources? These are the problems to be solved at the foundational level. While they can offer a lot more new services in terms of physical world being modeled as a digital twin with the sensing capability, or they could have a lot more intelligence coming to the edge onto the devices, how that can be enhanced through a right communication, right inferencing capability inside the network, and also how they can really offer a lot more new services as an AI grid provider or inferencing providers. So a lot more possibilities are coming to the telcos, but there are inherently several challenges to overcome to offer those services at the same time to operate the network efficiently with AI. But one thing to conclude, AI is inevitable thing. I think it is coming to the networks, and it is the thing that will happen very soon, is what our opinion.
Thank you, Ravi, on this. So I'll take few questions which came in the Q&A tab, starting with Sean. The first question is, we are actually considering data as a single set. We are not even distinguishing whether it's a centralized data set or a distributed data set. So do they require different set of data delivery collections and architecture? Over to you, Sean.
Okay, well, first I would say that when we look at the data architecture, I think 3GPP in general is very use case driven. So we have to understand all the various use cases for data. And as I mentioned earlier in my presentation, I think we see there's many data sources in the network. They all have very different characteristics in terms of latency requirements and the data volume. And so given this kind of diversity of requirements, I would not expect or assume that there's some kind of single centralized data set for all 6G use cases. Other functions such as like AI training, they may benefit from aggregating data across the network. Some other use cases may need data in real time. So I think this kind of naturally points towards probably a mix of both distributed and centralized approaches. The architecture probably needs to somehow accommodate both efficiently. I think it was clear from the earlier presentations, though, that there's still a lot that is open still in 3GPP. Even what constitutes data within the data framework. I mean, is it only going to be AI? Will sensing be considered data within the data framework, or will it be kind of a more specialized service where sensing data is transmitted directly from source to sensing function? But what's clear is that there's a lot of different data and we can't treat it all in the same way.
Yeah, thanks, Sean. Vinay, so I think you can also join the 3GPP RAN 3 and sort of evolve on what can be done for all these different data sets. Going to the next question, this is about, I think I asked the question to Alexi initially, do we need to change the hardware? Now people are asking, do I need to change the phone? Can I use my 5G phone as 6G phone? And if I don't do it, I would have to throw 6 billion of them into C. So how do I go about doing it? Satish, do you want to step in and answer?
It's too early to answer this question. But one of the day one requirements from operators, I mean, if you look at the discussion which is happening in 3GPP, is that 6G be a software upgrade on the 5G infrastructure. I'm still talking about the infrastructure. Phone is a different ballgame altogether. That's something to be seen. Thank you.
Thanks, Satish. Alexi, do you want to add anything? Would you make sure?
Yeah, I would never say please throw it into the sea. That's definitely not a good approach. But on another side, we can see that independent of 6G, the phones are renewed because the manufacturers of the phones, they stop supporting certain applications and so on. So it's not like the people are using the devices for 20 years. So they will be renewed if because of 6G or not. Yeah. So I expect, logically, I expect that there will be devices which will support new 6G capabilities, and if the people like to have them, then they will buy new phones or new devices. Yeah, but from the architecture point of view, from the network point of view, I'm with Satish that we should aim to have a software upgradable systems as much as possible.
Thanks, Alexi. I think, so that doesn't look possible, Dr. V.N. Shastri. Let's see, but we would, I think sustainability is a key problem for all the operators. There would be some way to recycle all of it. So there may be some swapping or something which may be possible from 5G phones to 6G phones when you move. But I think as such, there is no plan to upgrade your 5G phone directly to 6G. The next question is from Shiv Prasad. So this is basically to Satish. So how are you handling the data security for the owner or basically the end user? And the operator, are you worried about 3GPP standardization bringing AI into CSPs and ISP segment as well? Satish, and maybe after that, Javan can also add into that. Satish, over to you.
Yeah. So this whole business of AI in telecom networks is still evolving. So I mean, it's a question which is yet to be answered. But if you look at the broader debate of who the ownership of data ownership, that's in the AI domain. That's very much in the air today. Anthropic accuses Chinese of stealing their data and training their data sets using Anthropic data, whereas Anthropic itself stands accused in the EU courts of legal whatever battle that's happening, saying that copyrights have been violated. So the regulatory framework for protecting data still does not exist in the AI world. And there are certain governments, geographies who have been deliberately keeping this open for whatever interests. So that's where we stand right now. India has a data privacy policy which is still in draft, which is not ratified. So everything is up in the air as it stands today. Thank you.
Thank you, Satish. Javan, you want to add something?
Yes, thank you. First of all, I start with the last point that Satish sir said, that not everything is decided. In fact, I'm not as closely involved in 3GPP as Sean and others may be, but even 3GPP is also struggling with that and even asking legal questions from others. How do we proceed with this? First of all, if you allow me, on the data earlier question, I agree there's no one centralized point. And this also links to the next question, because there's multimodality, there's multi-party, there are 30 parties, there's fusion of data. What we need to focus on is orchestration of multi-domain, multi-layer data, and so on. But this question, I think it is promising that there is a global effort. I have also seen the launch of a World Data Organization. We go from data as an application or mere application to data as infrastructure, as well as data as responsibility. So this is exactly one area that needs work. And I have to say GTI Alliance, 160 Alliance are putting a lot of focus on this, including inclusive and responsible data. So there's questions to be answered.
Yeah, thanks, Javan. So I think we have a few more minutes to take some question. How will you enable native AIML? Sean or anybody wants to take that question?
Yeah, I could take a first step. So yeah, native AI, I guess it's kind of a buzzword that then, what does that practically mean when it comes to standardization? At least from my perspective, when I look at the RAN architecture, I mean, ultimately, what AI means to me and from a RAN architecture perspective is having access to relevant data. So it's more, the collection, the exposure, the exchange of information across the network and between domains. So I guess in my view, enabling that is what it means to be AI native.
Thanks. Anybody wants to add to that?
Can I jump in? Itsuma speaking.
Yeah, Itsuma,
Thanks.
please go ahead.
Yeah, from my perspective, well, really depends on what AI native really means. But my analogy here is always like this. There's a big question whether operator wants to have manual control options, like flying a plane, flying a jet plane. Now pilot have all the tools available so that in case of AI not working, the pilot, the human, can interrupt and fly the plane. Whereas there's a fully autonomous network car where the driver doesn't have access to any manual tool to drive a car. That's the big difference. And the big question for 6G is which one do you want? Yeah. And so the question, to answer the question, how 6G architecture will enable native AI is ultimately up to the operator and industry decision to give up manual control on many things. And whether we can do this, it's more maybe a business management question. But I want to add that to the perspective. Thank you.
Thank you, Itsuma. The next question is quite controversial, and I will leave it to the government to answer. Are you going to actually listen to all the conversation which is happening in the cellular network? Is that considered as an AI data? Ashok sir, do you want to comment on that? How will you prevent such things from happening?
Jishnu, I missed your questions.
So the question is, so this is from a media nama. I think it's a media company. So they are asking, would my conversation which happens in cellular network, would it be part of AI data? Would that be consumed by operators and vendors to learn data? Which at least I can clearly say it's not allowed. But how will regulatory mechanism be built up so as to prevent conversations which are happening during over phone are not used as AI data and it remains secure?
So whatever we are talking will be governed by the whatever act and rule which we have in place. So the Telecom Act which is in force and the new Telecom Act which has actually come in force. So that doesn't allow like personal data to be kind of shared with anyone without consent of the user itself. And that will also be a case one DPDP Act which is in draft stage today becomes effective. So there also such restrictions would be there. So what kind of data set AI can use for model training? If some policy or regulations are required, that will be perhaps will be first discussed. I mean, the way we kind of evolve a particular rule or particular regulation through consultation process, that will actually happen, and then only some decision will be taken. So as of now, as a citizen, no one should worry about his or her data to be used for AI training without their consent.
Thank you, sir. I think, yeah, that is true for all of us, operators, vendors, etc. Nobody wants to use proprietary conversational data to train anything. So rest assured on that. The next question is, how is slicing going to evolve? This is from Lakshmi. Anybody wants to take that? Alexi, do you want to try?
Yeah, I can try. Because we try to introduce it, obviously, also in 5G, because we operate 5G standalone networks. And let me put it that way. In my opinion, the slicing will survive and will develop. And the idea behind is actually pretty good. Yeah, because you give a certain, let's say, not a prioritization, but a special treatment to particular customers based on their applications or contracts and so on. So that enables you to provide special services, let's put it that way, or the special treatments of particular services for particular groups of the customers. How it is realized in 3GPP right now, that is a big question. Because currently you can see that there are players in the market, I will not call now the names, which actually kind of prevent using it, by their products and systems and so on. So that's why it is probably not very successful so far on a broader scale. Does not mean it's not successful by Vodafone, but on a broader scale, I think after 10 years, we should see much more success of such functionalities. But as I said, the functionality itself is pretty good and pretty fancy from the marketing perspective also. But technical realization might need certain changes, in my view.
Thank you, Alexei. Next question, maybe Ravi can take it. Are we seeing subsea data centers being built up? Is that the way to go forward? Because I think people are concerned about water being consumed by all this data center. Are you working in data centers which are actually undersea?
Not really at this moment, but I think these are all the possibilities people are talking about, whether it's data centers in the space or in the sea. I think these are the possibilities to improve the energy efficiency and also to reduce the cost of operations. But as of now, there's a lot more to do with respect to the chip design, to the system design, to the overall the rack design itself for all these possible deployments, right? I think these are the future possibilities. As of now, I think little far away.
Thanks, Ravi. One more question I will take. It's from Purnima in HFCL. So is the 6G network function becoming more cloud native, microservice based, where operators can deploy or upgrade individual network function independently instead of deploying the entire network stack? Alexei or Itsuma, do you want to comment on this? Is it becoming, can you just take some microservice from somebody and just deploy it? Is that become such an easy thing in core, 5G core? Can you get a network function and deploy it? Say, for example, if I have to do sensing, can I just take a sensing network function and get it deployed?
Yeah, I think actually the change to SBI architecture in 5G core, it generally enables it. Yeah, it is simpler. Yeah, to introduce new functions. That does not mean that there are no restrictions. Yeah, but in general, I think the answer on that is, if it's between yes and no, then yes. Yeah, it becomes simple.
Thank you. I think there was one more question, which is regarding Geo IPO, which I don't think legally it is allowed to discuss. So I am not taking that question. So thank you, all of you. And I'll just go one by one, and maybe you can comment the way forward as a conclusion if you have anything. First to Alexei.
So, yeah, first of all, thank you very much, everyone, for this panel and for the great presentations and the chat. From my side, just a few words. So, first of all, I was really impressed by what Satish said, because it is kind of a view I share in a large extent, but we also need to consider. And this but is important. All technologies we introduced so far, they came with a new spectrum. And most of them, they became successful. So the 6G will also be paired with a new spectrum, in my view. And that's why I also think it will become successful at the same time. Then there is the next thing. We are speaking about new services, and we have spoken about new services in 5G, in 4G, and 3G, and also in 2G. And almost in every technology, we were totally wrong. So we always said there will be new service and described it and so on. The reality in 5 to 10 years was totally different. Yeah. And some of the services we said, oh, they're almost dead. They came back again just later. So considering all this, I still believe that we have to develop a very efficient system, and I'm quite sure we will find a good use out of that. And with that, I would like to thank you all again. Thank you.
Thank you, Alexei. Ashok sir, any one small statement before we close? You're on mute, Ashok sir.
Oh, okay. Are you okay? No,
Yeah.
I guess also I'd like to thank everyone for listening to the presentations, and maybe what I'd like to leave with is that I think a common theme here is that we're still at a very early stage of 6G still. You know, this is a very exciting time, for example, in 3GPP, defining the technology for the next generation. And I'd like to extend, I think, the invitation that Jishnu said earlier for somebody to come to RAN 3, I think everyone is welcome there. Because again, I think in the next 6 months, a lot of important decisions will be made.
Thank you, Sean. Ashok sir.
Yeah. So thank you. Since in the panel, we have a lot of experts from standards and industry and OEM. So the message or the last word, as you say, I would like to say that what we did in 5G, having a 6 deployment option in 6G, let us, I mean, as the discussion going forward, have a single sort of a minimalistic release, which is 6G release, not like NSA one, which we have. Because of that, a lot of complication. The second thing which we are talking is that kind of a spectrum sharing, multi-rad spectrum sharing. So in 5G, the dynamic spectrum sharing perhaps was not very, very efficient, and it was not deployed by many of the operators, all because perhaps if you try to use the 4G spectrum for 5G, one is the channel bandwidth is less, and second, you get to lose a lot of resources. So whatever we do for 6G, perhaps we should consider that the spectral efficiency after this kind of sharing is good enough to support 6G services. Then again, question of carrier aggregation and dual connectivity, a lot of, even today, a lot of problems with dual connectivity with 4G, 5G. When in 6G, perhaps, let us see that these are smooth and we are able to support the legacy devices also. That comes the interoperability of existing. So still today we have 2G handsets, 3G, 4G and 5G handsets. So along with 6G, whether our handset would have modems for 2G, 3G, 4G, 5G, 6G, or we want to sort of optimize considering the cost and also the complexity of the devices. We are talking about NTN integrations, although the panelists said that there is cost involved in the satellite is very huge. But the one thing which has to, everyone has to remember is that from the government perspective also, there are a lot of area which is unconnected today. So we have to rely on satellite-based services. And if there is an interworking, if my mobile device itself can work, or maybe some other form factor, it will be good. So we should continue kind of talking about NTN support or NTN integration with the 6G or 5G advanced. On the front of AI/ML, so we cannot like now move away from AI/ML because it's coming for every application, every service, everywhere AI is being embedded. So only thing which I would like to say on AI/ML is that the architecture should just have a framework, wherein a lot of other model can fits into a lot of innovation space we should leave for a private enterprise to build, which can just be fit into the system so that you can use best of the system available at that point of time, instead of like fixing some of the models for different purposes in 5G, in 6G. And the sensing talk was also there, that how we can integrate sensing. So sensing we had been doing from very, very, very old time, radar and all, but now we are talking about sensing capability inside the radio, the 5G, 6G radio itself. So first of all, we should look at what kind of use case I can offer and how operators can monetize even before some investment goes into that. So it's very fancy to have sensing capability in every tower, but what are the real use cases I can support today or tomorrow? So unless I have a clear visibility, perhaps investment into that may not be the problem. The security aspect also.
I think we don't have time, so maybe we'll
Okay,
others will not get
there's a
time.
lot of idea. Maybe I
Yeah,
write down and
sure.
send
Thank you, sir. I think Ravi, Satish, Javan, just
Maybe if I
maybe.
can take a last moment, thank you for having us here. I believe that 6G is going to enable the telcos, right, as a techco companies or a technology companies, right? So far it's a data pipe, but the 6G, true 6G standardization is bringing a lot more capability. And that is enabling a lot more, data generation capabilities and so on with the telcos. And telcos could become a true web scale players going forward that can change the overall the monetization capability, and also offering a lot more diverse products to the market than a connectivity. That's what I believe in. With all that people are talking about, if really that AI comes to the consumers, AI comes to the enterprises in a big way, with the telcos becoming technology companies, so they can serve this market in much better way with a lot more offerings. That's what I see.
Thank you, Ravi. Javan?
Yes, thank you. I'll be brief. First of all, thanks from my side as well. I think we should be optimistic. I think we should embrace possibilities. We are talking about the next decade. There are needs, for example, energy efficient, ubiquitous connectivity, mobile AI intelligence, ubiquitous intelligence that can address a lot of questions. We need to become global, also engage in research and in alliances such as GTI-1, 6G, Bharat. There are realities early to answer. We should have design principles for our challenges, like leverage investment, interoperability with 5G, simplification, scalability, but at the same time, embrace all these innovations and mobile connected, ubiquitous intelligence will serve the society, the work and governance. Thank you.
Thank you, Javan. Satish, I think
Yeah.
you are into
Briefly.
Sonali's time, so maybe 1 minute.
Yeah. So two things which hardly gets discussed but will shape 6G will be the geopolitics, which people don't talk about. I don't want to talk about it. I'll just name it as geopolitics and leave it at that. And the other part is the silent militarization of the 6G network. Sensing, if you ask anybody on a coffee table, they'll readily agree that one of the biggest customers is going to be the military. And you say military, then obviously the government will step in. There is geopolitics. There is every other possibility. These two factors, which typically don't get discussed a lot, but then I believe will have an extraordinary influence in the way 6G shapes out. Thank you.
Thank you, Satish. Over to Sonali to conclude. Before that, can everyone come online and we'll take a nap? Do you want to do that before or after, Vaishali? Maybe Sonali, you can finish it and then we'll take a snap of everyone to that.
Yes, sir.
Okay.
Thank you, Jishnu.
Thank you. Sorry for taking your time to conclude, but I think everyone concluded for you. So maybe you can make it very short.
Yes. So everyone, as we bring this session to a close, allow me to draw together the threads of what has been a genuinely rich afternoon of keynotes and discussion. Sean gave us a phrase I suspect we'll all carry out for this session is 6G architecture should be framed neither as evolutionary nor revolutionary. It should be disciplined evolution. And innovate to enable new frontiers, reuse where it delivers value was one key takeaway which I'll take from his talk. Alexei reinforced that discipline from the operator side. Rather than defining a new 6G core network architecture altogether, we build upon what we have with 5G. And with every architectural choice must be weighed against energy consumption and processing power. Docomo's keynote, reminded us, as we have discussed earlier as well, that through Japan's lived experience of earthquakes and typhoons, that the network's deepest purpose is to keep people connected, whatever the circumstances. And the conviction now is driving coverage extension across sky, sea, and space. which is combined with LXC's call for TN, terrestrial and NTN network. And we are, from day one, we are rooting for a common design, and we are thinking, and we are aspiring that these should not be stitched together after the fact. Little bit of concluding summary on keynote speakers. Ravi told us that AI will bring 3 distinct things for telcos: autonomous network, AI nativeness across the entire network stack, and AI as a new revenue generator with the capability 6G brings. Javan pointed out to the role of alliances and research institutes alongside the standard bodies, where we talked about validation and bias mitigation for AI agents, concrete opportunities such as cooperative and coordinated system. We talked about UAV swarms, we talked about trajectory management, we talked about AI combined with sensing for energy efficient operation. On the other hand, Indian operator Satish gave us the cautionary tale on the, a disruption with the AI training data set, that how the demand for the common data set is emerging and how this could actually, drive in a certain other direction. Ashokji described how the government of India is driving an ecosystem-driven approach from the indigenous 4G network stack and 5G end-to-end testbed to a similar stack that will continue to be developed for 6G. With the DoT actively supporting startups and MSMEs, which also was added by Satish, where we discussed about FWA evolution aspects, which directly speaks about our deployment realities. In this precisely, we talked about, our operators, vendors, startup, academia. We all aspire to carry India's priorities, global priorities on rural connectivity, affordability, FWA, NTN, terrestrial and NTN integration into the global debate. I'll end this concluding remarks by one of the key takeaway, which I have taken from Tanaka-san's keynote, that if you want to go fast, go alone. If you want to go far, go together. So this is the key takeaway which we take today, that no single organization can build the future of 6G alone. The architectural conversation begin here will continue across the sessions of this conference, and more importantly, in the contribution we all carry into standardization bodies, regional standardization body like TSDSI in the months ahead. Let me sincerely thank our distinguished keynote speakers, Mr. Alexei Kulakov, Mr. Itsuma Tanaka, Mr. Sean Kelly, and for their insightful addresses, and our panelists, Mr. Ashok Kumar, Mr. Javan Irfanian, Mr. Ravi Imani, and Mr. Satish Damdagani, all in alphabetical orders, for such a candid and wide-ranging discussions. My co-chair, Mr. Jishnu, for moderating the panel so efficiently. Shefali ma'am, once again, for her opening remarks. Our convener and SGN advisor, Shri V.K. Roy. Our coordinator, Ms. Vishali Agarwal, and the TSDSI Secretariat. But, and also in the end, and above all, this engaged audience. Before you leave, do take a moment can we have a next slide where we display the QR code where you can please share your feedback. Thank you, and we look forward to your continued participation in the rest of TTDD 2026.
Thank
Signing
you,
off
Sonali.
on
Can
behalf
we-
of Jishnu and I. Yes.
I think maybe can we get everyone on the snap for a snap? Can all of you switch on the videos just for yeah.
So we have one announcement.
Okay, please go ahead.
Yeah. So thank you, Sonali ma'am, for your inspiring concluding remarks. Before we conclude, we kindly request all participants to share their valuable feedback on today's session. Your feedback is extremely important to us and will help us further enhance future editions of the TTD conference. You may submit your feedback by clicking on the feedback link shared in the chat window or simply scanning the QR code displayed on your screen. We sincerely appreciate you taking a few moments to share your thoughts. Thank you. And thank you once again for your enthusiastic participation and engagement through the session. We warmly invite you to join us for the next insightful session of TTDD 2026 titled AI Native 6G. Have a wonderful conference experience, and we look forward to your continued participation. Thank you. Now I request you all to switch on their cameras for a picture.
Able to capture everyone?
Done, sir.
Done, sir. It's done.
Okay, thank
Thank
you.
you, everyone.
Please attend the next session.
Thank you.
in Another 5 minutes. Thank you.
Thank you.
Thank you.